Hi guys, in this tutorial I'm gonna solve question number 7, June 2020 paper 41. Particle P of mass 0.3 kilogram lying in a smooth plane, so we have no frictional force on inclined plane which makes an angle 30 with horizontal, is released from rest. So we start from initial velocity is equal to 0 and P slides down the plane for a distance 2.5. So the displacement, all these information given on the plane and reach the horizontal plane. There is no change in speed when P reach the horizontal plane. It's given this is information, so you can use the end velocity of the inclined plane is start velocity for the horizontal plane. There is no change in this velocity. A particle Q of mass 0.2 kilogram lies at rest, so velocity is equal to 0 on the plane. 1.5 meter from the end of the inclined plane, P collide directly with Q. Look, let's start now to look at part A. Given that the horizontal plane is smooth, when it's given the horizontal plane is smooth, when the particle P reaches the ground, continuous with the same velocity because it's smooth. After the collision, P continues moving in the same direction with the speed 2. Find the speed of Q after the collision. Let's start first with particle P released from rest. So the initial velocity is equal to 0. You have to find the acceleration. We can apply second law of Newton when the particle release. All the forces in direction of motion, mg sine theta, minus all the forces in opposite direction, which is, there is no frictional force. So you can write 0 is equal to ma. So the particle, we can remove mass. So the particle move with acceleration g sine theta. G is 10, sine theta, sine 30, which is half. So the acceleration is 5. Then you can find the final velocity at the end, v squared equals u squared plus 2as. So v squared is equal u squared 0, 2 times, acceleration is 5, and displacement is 2.5. From this equation, 2 times 5, which is 10, times 2.5, 25, by taking the square root. So the final velocity is equal to 5. We can calculate this value by using lossing kinetic is equal, gaining kinetic is equal to loss in potential energy. When you release particle P, you can find the vertical height because it's smooth. So mgh is equal to half mv squared. Loss in potential energy is equal to gain in kinetic energy. You can remove mass with mass. So g is 10, h the perpendicular height, which is 2.5 multiplied by sine 30. This is 2.5 multiplied by sine 30 is equal to half v squared. By solving this equation, you will get the velocity same is 5. It's 10 times 2.5 times sine 30. So the answer multiplied by 2, then by taking the square root, you will get v is equal to 5. So the particle P now at the end, but continuous on the plane because it's smooth. So hit this particle with a speed 5. Now momentum before the collision is equal to momentum after the collision. So mu plus mu. This is for particle P, this is for particle Q, is equal mv plus mv, particle P, particle Q. If you use your direction positive to the right side, if it is m mass of P, which is 0.3 times velocity before is 5, plus mass at Q 0.2 times 0. It's given that P continues to move with the same direction, but speed now is 2. So 2 times 0.3. 0.3 times 2 plus 0.2 times V of Q. He asked to find the speed of Q after the collision. Now simplify the right-hand side, which is 1.5 is equal to 0.6 plus 0.2 velocity of Q. From this equation, you can find the velocity of Q, 1.5 minus 0.6, so divided by 0.2. So the final answer is 4.5 meter per second. So particle Q move to the right side with velocity 4.5 meter per second. Look at part B. It's given that instead the horizontal plane is rough and that when P and Q collide, they coalesce and move with the same speed 1.2. Find the coefficient of friction between P and horizontal plane. We'll start from the end now. Before the collision, we don't have velocity of the particle P, but we have velocity of particle Q. Again, mu plus mu is equal to mv plus mv. Particle P, particle Q, particle P, particle Q, apply the equation. M mass of particle P is 0.3. Its initial velocity, we don't have it, so leave it UP, plus mass of Q is 0.2 times 0 is equal mass of P 0.3, mass of Q 0.5, 0.2. When you take V, Q and VP are same, it's given 1.2. From this equation, we'll find the velocity before particle P collide with particle Q. You can find UP is equal 0.3 plus 0.2, which is 0.5, multiplied by 1.2, then divided by 0.3. So the answer is 2. Now, particle P, this is the inclined plane. This is the horizontal plane. Particle P, now I will use the final velocity 2, but we have initial velocity found in the previous part, which is 5. And the displacement in horizontal plane is given 1.5. 1.5. You can find the acceleration in this part. V squared equals U squared plus 2AS. The final velocity is 4. Initial velocity is 5 squared, 25, plus 2 times acceleration times displacement, which is 1.5. From this equation, you can find S, 4 minus 25, then divided the answer by 2 times 1.5. It's given -7. The particle decelerating with -7. When you write second law of Newton, particle P move in a horizontal plane because of inertia. When you apply force, in direction of motion is 0, but in opposite direction is frictional force is equal to MA. He asked to get the coefficient of friction. When you apply second law of Newton, all the forces in direction of motion minus all the forces in opposite direction is equal to MA. And R is equal to mg, frictional force is equal to mu r. From the first equation, frictional force is equal mass times acceleration. So you can find the frictional force is 2.1 Newton. And also you can find the normal reaction, 0.2, 0.3 multiplied by 10 will be 3 Newton. The coefficient of friction is the ratio between the frictional force and the normal reaction. So the friction force is 2.1 and the normal reaction is 3. 2.1 fraction, 2.1 divided by 3. So the answer will be 0.7. So the coefficient of friction is equal to 0.7. That's it. Thank you.